Introduction. Good morning, everyone. Today, we'll explore the human digestive system, focusing not just on the anatomy and physiology, but also on its clinical importance. As future doctors, understanding the digestive system's functioning is critical for diagnosing and managing various gastrointestinal (GI) disorders. Let's dive into the journey of food through the digestive tract. 1. Overview of the digestive system. The digestive system is a complex set of organs that processes food, extracts nutrients, and expels waste. It has two main components: the GI tract, a continuous tube from the mouth to the anus. Accessory organs, the liver, gallbladder, and pancreas. The digestive system performs four major functions: ingestion, taking in food; digestion, breaking down food mechanically and chemically; absorption, transferring nutrients into the bloodstream; excretion, eliminating undigested material and waste. 2. The journey of food, step by step. A. Mouth. Digestion starts in the oral cavity. Teeth break down food mechanically. Salivary glands secrete saliva containing amylase, which initiates the breakdown of carbohydrates. The chewed food, now called a bolus, is pushed to the back of the throat by the tongue for swallowing. Clinical note: disorders like xerostomia, dry mouth, affect the initial digestion of carbohydrates and overall oral health. B. Esophagus. The esophagus is a muscular tube that transports the bolus to the stomach via peristalsis. The lower esophageal sphincter, LES, prevents acid reflux. Clinical correlation: dysfunction of the LES leads to GERD, gastroesophageal reflux disease. Achalasia, a failure of the LES to relax, can cause difficulty swallowing. Stomach. In the stomach, both mechanical and chemical digestion occur. Mechanical digestion: the stomach churns food into a semi-liquid form called chyme. Chemical digestion, HCl, lowers pH 1.5-3, denatures proteins, and activates pepsinogen to pepsin. Pepsin begins the breakdown of proteins. Clinical relevance: the stomach's mucosal layer protects it from acid. Disruption of this barrier leads to conditions like peptic ulcers. Parietal cells secrete intrinsic factor, crucial for vitamin B12 absorption. A deficiency causes pernicious anemia. D. Small intestine. The small intestine is the primary site of digestion and absorption. It has three parts: duodenum, digestive enzymes from the pancreas and bile from the liver act here. Pancreatic enzymes, amylase, lipase, protease, break down carbohydrates, fats, and proteins. Bile emulsifies fats. Jejunum absorbs most nutrients, including glucose, amino acids, and fatty acids. Ileum absorbs vitamin B12 and bile salts. Key features: the intestinal lining has villi and microvilli, which increase surface area for absorption. Clinical correlation: diseases like celiac disease or Crohn's disease affect nutrient absorption, leading to malnutrition or diarrhea. E. Liver, gallbladder, and pancreas. These accessory organs are essential for digestion. Liver produces bile for fat digestion, detoxifies substances, and metabolizes nutrients. Gallbladder stores and concentrates bile, releasing it during digestion. Pancreas, exocrine function, secretes digestive enzymes and bicarbonate to neutralize stomach acid. Endocrine function, produces insulin and glucagon. Clinical relevance: gallstones can obstruct bile flow, causing pain and jaundice. Pancreatic insufficiency, e.g. in chronic pancreatitis, impairs digestion. F. Large intestine. The large intestine absorbs water, electrolytes, and forms feces. It has four segments: ascending, transverse, descending, and sigmoid colon. The gut microbiota here helps digest undigested food and produce vitamins like K and B12. Clinical correlation: dysbiosis, imbalance in gut flora, is linked to conditions like irritable bowel syndrome, IBS. Colon cancer commonly affects this region. G. Rectum and anus. The rectum stores feces, which are expelled through the anus during defecation. The process is controlled by both involuntary, internal anal sphincter, and voluntary, external anal sphincter, muscles. 3. Nervous and hormonal regulation. The digestive system is regulated by enteric nervous system, ENS, known as the second brain. It controls gut motility and secretion independently. Hormones, gastrin, stimulates acid production. Cholecystokinin, CCK, stimulates bile and pancreatic enzyme release. Secretin, stimulates bicarbonate secretion. Clinical relevance, stress and conditions like irritable bowel syndrome, IBS, highlight the connection between the ENS and the central nervous system, CNS. 4. Summary of clinical relevance. Understanding the digestive system is critical for diagnosing and treating GI disorders, such as GERD, ulcers, and acid reflux. Malabsorption syndromes like celiac disease. Liver diseases like hepatitis and cirrhosis. Disorders of motility, such as IBS or constipation. Conclusion. In summary, the human digestive system is a well-coordinated mechanism that ensures we obtain energy and nutrients while eliminating waste. Its clinical importance cannot be overstated, as it serves as a foundation for understanding both health and disease. Thank you for listening, and I hope this discussion deepened your understanding of this vital system.